Welcome back. So this video includes more information about atoms and about the purpose of each subatomic particle. So hopefully at this point you guys should be familiar with something called the periodic table, which is just this table that includes all of the known elements. The most important subatomic particle to the periodic table is the proton. This is because the number of protons an atom has determines which element it is. For example, on the periodic table, when reading from left to right, element number 53 is going to have atoms with 53 protons, and by coincidence, this is iodine. So if the number of protons an atom has determine which element it is, what do neutrons do? And also, what do electrons do? To answer this question for neutrons, let's take a look at a helium nucleus, which contains 2 protons. Now we already know that protons have a positive charge, and because we also know that like charges repel, there's going to be a strong repelling force between these protons. What allows the nucleus to stay together and not just fly apart is this force called the strong force, which acts between subatomic particles. Neutrons, because they don't repel protons, act as the glue for this force in a sense. Neutrons provide a medium for the strong force, but at the same time provide the necessary spacing between the protons so that the strong force can overcome the repulsion of the like charges. Neutrons can really be thought of as the glue that holds atomic nucleuses together. Different atoms of the same element can contain different numbers of neutrons. This number of neutrons determines which isotope of their respective element an atom is. For example, atoms with 1 proton are all hydrogen atoms, but they can contain 0 neutrons, 1 neutron, or even 2 neutrons, but they're still hydrogen atoms. However, not all of these combinations are stable, and we will later discuss which combinations are stable and which ones aren't. Alright, so now let's move on to electrons. If you remember the basic structure of an atom, you remember that there is a nucleus with protons and neutrons in the center, and a cloud of electrons on the outside. This cloud of electrons has a negative charge because electrons are negatively charged. However, the nucleus in the center only has protons, which are positive, and neutrons, which are neutral, so it has a positive charge. The charges of protons and neutrons are equal in magnitude but opposite in direction. This means that if an atom has equal numbers of protons and neutrons, it will be a neutral atom. However, if there are more electrons than protons, the atom will be considered a negative atom because there are more negative charges. The same is true for the relationship if there are less electrons than protons. The atom will then be positive because there are more positive charges than negative charges. Again, this is only possible because the charges of electrons and protons are equal in magnitude but opposite. That's it for this video. See you in the next one.